Hi everyone. Now in this video, I'm going to explain about the dissolution process of an ionic solid. So this topic is actually still related with Hess law, the one that you have learned before. Okay, now when we say ionic solid, it is about, ionic solid, for example, like salt, okay, obviously salt. So there are ionic solid and they are the one that we are talking about. And imagine you have a salt and you dissolve it in water. So this is the process that we are talking about, dissolution process of an ionic solid. So you guys can read the definition at the page 35, okay? And then I will just directly go to the process, okay? So we know when we are talking about the dissolutions of ionic solid, you can imagine like something like sodium chloride, and you dissolve it in water, and you're going to get sodium aqueous and chloride ion aqueous, okay, something like that. Okay, however, to have this, okay, this one, if you remember, this is related with enthalpy of solution. But there are actually many steps that you can do to finally get it to this part. Okay, so I make it simple. You guys can actually read the example here. So we have dissociation lattice and we have hydrations of ions. Okay, so how is it goes on? Okay, I'm just directly going to use sodium chloride. So we know we have sodium chloride. It is a solid, and we dissolve it in water to produce, we dissolve it in water to produce sodium ion but aqueous and chloride ion that is aqueous. So basically ini you campur dalam air, ting, and you get the solution. So this is the solution. And enthalpy involved here is enthalpy of solution. Okay, for example, something like that. Now, we can also relate this with, okay, we can also relate it with, another one enthalpy that we call as lattice energy. So lattice energy is, okay, if we have here, where do we have? Yeah, this one at page 37. Now, lattice energy, as you can see, the definition. Okay, there are two types of lattice energy. We'll have the lattice energy of formation or lattice energy dissociation. So basically, like lattice energy dissociation from sodium chloride, okay, from sodium chloride, it is break into sodium gaseous ion and chloride gas ion. So this is lattice energy dissociation. The word lattice itself means ionic solid. So easy to say, ionic solid pecah. Okay, dia pecah and it become gaseous ion. But when we are talking about lattice energy formation, we are forming the solid ion. Okay, which is, it is reverse one from sodium ion gas. Sodium ion gas and chloride ion gas, they combine together to form sodium chloride. So that is what is meant by lattice energy formation. So usually for lattice energy formation, energy will be released. But for this one, energy for lattice energy dissociation, energy will be absorbed. Why? Energy is absorbed to break this, so that it can form this and this one. Okay, so again, lattice means ionic solid. Lattice energy dissociate means we break up the ionic solid. So berapa banyak energy involved? Alright, okay. So read this at page 37. So I'm going back to this. And therefore, we are going to get sodium gas. Okay, wait. I think I would like to erase it first. Okay. Sodium gas plus chloride ion gas. Okay, so this solid, it is break up to form this gaseous sodium ion and gaseous chloride ion. So enthalpy involved here is, this one is lattice energy. And look at the arrow. Now, since the arrow is going from the solid to the ion, this one means it should be positive. Okay, it should be positive. And the next one, okay, is when sodium gas ion, okay, turn into sodium aqueous, or chloride ion gas turn into chloride ion aqueous. So enthalpy involved here is hydration. Okay, so this one also hydration. Sorry, enthalpy, hydration. So according to Hess law, if you still remember, I said to you, the skill, you need to know the two ways. Arrow, so this is the arrow, 1, 2. So this one is the sum of it. Which, in other words, enthalpy of solution is equivalent to enthalpy of lattice. It must be positive. Okay, make sure it is positive because it is breaking up. Plus this one, enthalpy of hydration for sodium ion plus enthalpy of hydration for chloride ion. Okay. Maybe you might wonder, madam, can it become like this? Wait there, I copy first. Copy and then I paste it down here. Okay. You might wonder, madam, is it possible if my arrow is this? Okay, so I make it reverse. Yes, it is possible, but in this case you have to understand. If you make the arrow going from gaseous ion and forming sodium chloride, therefore the lattice should be negative. Okay, and why it is negative? Because you need to release heat to form the solid ion. Okay, and therefore this one should be negative value. Hydration and chloride will stay just the same. Okay, so I will give you this later on in the group. Okay, so you have to understand that when you're talking about, if you want to explain about enthalpy of solution, it is related with lattice dissociation enthalpy and also enthalpy of hydration. Okay, so again, lattice dissociation, it must be from, if I can explain again, it must be from solid ion and it must produce sodium gas ion, positive ion gas and negative ion gas. Okay, and then for hydration, it must be from gaseous ion. This is wrong, everyone. Please change in your, this is aqueous. Okay, all right. So let's take a look at one example for this one. Okay, let's see this example. So based on the data given below, you have the enthalpy of hydration for sodium ion. You also have the enthalpy of hydration for chloride ion. And you also have the enthalpy of solution for sodium chloride ion. The question is, construct the energy cycle diagram to represent the dissolution of sodium chloride. So let's construct it, starting with this. Okay, so this is enthalpy of solution. We know from sodium chloride solid, it will turn into aqueous ion. Okay, and the enthalpy involved is, okay, in this case you can just write positive 6 kilojoule. Okay, next one. Sodium. I like to make it like this. Why, madam? Because I just want to make it straight later on. So yeah, there you go. Pop like this. Okay, and this. Okay, we don't have the energy of lattice energy for NaCl, so we just put it like this. Lattice, which is equivalent to ding. We don't know. Okay, and then the next one, we have the enthalpy of hydration for sodium aqueous. We go up. It must be from gaseous ion to aqueous. So the enthalpy involved is negative 390 kilojoule. And this one, enthalpy negative 380 kilojoule. Okay, so this is the energy cycle. You must have the enthalpy with the, wait, let me give you some insight. You must have the unit. Okay, you must have this enthalpy, and all those particles that you wrote, you must have the phase. And this one also mark. Okay, overall you will get full marks, around 3 marks for this. Okay, next one, number 2. Calculate the lattice energy of NaCl. It doesn't mention whether it is the lattice energy of but because this question is dissolution, right? Okay, so never mind, you just write what lattice you get. So we have here, should be solution equals to lattice plus enthalpy of hydration, which is the combination of hydrations of sodium gas and chloride gas. So we have here positive 6 kilojoule. We don't know this. Plus negative 390 kilojoule minus 380 kilojoule. Okay. So bring tum-tum, you calculate it, and you get enthalpy lattice equivalents to positive 776 kilojoule per mole. You might wonder, madam, this is not enthalpy of whatever, right? But lattice energy is also referring to 1 mole. Therefore, you must write the unit per mole. And there you go, you have this. Okay? So maybe you can give a try for this one, question example 2. Okay, and then I will give some extra from the mastery practices. Okay, that's all. Thank you, everyone.